We can conceive of any rhythm, even the most complex rhythms of our fancy, as being formed from the simplest of building blocks. By turning our attention to the smallest units of musical form, we increase our ability to perceive and to shape structure in what we compose. As with any artistic medium, reflection on symmetry or asymmetry and how individual parts relate with one another and to the whole opens up creative possibilities we might otherwise overlook. Part 1. Permutations of Rhythmic Cycles. Today, let us explore the different rhythms possible in a cycle of a given length. 1. One beat. With one beat, we have but one dimension, a point in time. An event defined just as much by the silence surrounding it as by the sound itself. The basic backbone of the flow of time as a now and a now and a now with nothing in between. 2. Two beats. With two beats, there are two possibilities. In the first, both beats sound. In the second, one beat sounds while the other is silent. Note, the first sounding beat provides us an obvious point to define the beginnings of our cycles. Let us leave aside rhythms where the first beat is silent. We can consider such rhythms as variations of what we defined here. This doubles the number of rhythms we can define with a single diagram. It also helps us to avoid scenarios where all beats of a cycle are silent. Complete silence is a topic all unto itself. 3. Three beats. With three beats, possibilities start to unfold. At the top, we find one rhythm where all three beats sound. From here on, we will refer to sounding beats as onsets. Here, onset means the start of a sound. Below this, we find two rhythms with two onsets and the remaining beat silent. At the bottom, a rhythm with one onset and the other two beats silent. This is a good place for us to pause and examine the structure of these diagrams. First, notice the bold numbers at the outside ring of the diagram. At the top is 0 and not 1. This may seem confusing at first, as we typically count rhythms with 1 as the first beat, not 0. But putting 0 at the top is useful as we are measuring cycles of time. Imagine the face of a clock. 1 appears not at the top, but 1 unit clockwise from the top. This is because it marks 1 minute or 1 hour or 1 second from the start of the cycle of 12. The top, position 0, marks the start of the cycle, not the first completed unit. The same principle applies for our diagrams. It will also become useful when we apply the same type of diagram to musical scales, modes, and harmonies. The small numbers toward the inside of the diagram mark the count of the rhythm. In this case, the rhythm at the top can be counted 1, 1, 1. The next level down on the left, 2, 1. The same level right, 1, 2. And the rhythm on the bottom level, 3. The large number at the center of the disc simply tells us how many beats there are in a cycle. The lines connecting the discs display rhythms that can be attained by subtracting or adding one onset, or a hemming distance of 1. 4. 4 beats. With 4 beats, we can move in 3 dimensions. That is, by adding or subtracting one onset, there are 3 different rhythms we can move or transform to. There is 1 rhythm with 4 onsets, 3 rhythms with 3 onsets, 3 rhythms with 2 onsets, and 1 rhythm with 1 onset. A pattern begins to emerge. Pascal's triangle. With 1 beat, we had only 1 rhythm. With 2 beats, 2 possible rhythms. With 3 beats, 4. 1 plus 2 plus 1. With 4 beats, 8. 1 plus 3 plus 3 plus 1. And so on. And so on. We can observe how rhythms relate to and interconnect with each other. We can see how one rhythm can transform into another through minimal changes, adding or subtracting a single onset. Some rhythms reflect others in symmetry, and how those rhythms interplay in a relationship of balance. Relatedness, interconnection, transformation, symmetry, balance. All of these and their opposites are worth our consideration in making any type of art. Five beats. And indeed, in a cycle of 5 beats, where the first beat is always an onset, we find 1 rhythm with 5 onsets, 4 rhythms with 4 onsets, 6 rhythms with 3 onsets, 4 rhythms with 2 onsets, and 1 rhythm with 1 onset. We can also take notice that the rhythms that fall toward the center axes of our diagrams, particularly the vertical axis, show more symmetry than those that fall to the outsides of the diagram. We will explore how this is useful in later chapters. Six beats. Pascal's triangle and our diagram show us that a rhythm of 6 beats, where the first beat is always an onset, will have 1 rhythm with 6 onsets, 5 rhythms with 5 onsets, 10 rhythms with 4 onsets, 10 rhythms with 3 onsets, 5 rhythms with 2 onsets, 1 rhythm with 1 onset. We could continue, but the interconnections become so complex that they are seemingly impossible to represent and comprehend in 2 dimensions. We can easily, however, combine smaller rhythms to build the longest, most complex rhythms we desire.